Howdy hey, this is going to be the tutorial for P03 side plate. Let's jump across to our pulley project facts document that we've downloaded off the LMS, and we can see the component just here on page 2 of that PDF. It's sort of an egg-shaped metal plate. We can see the bottom is a little bit rounder, a little bit larger than the top. We've got 2 holes which are 90 millimeters apart from each other, and then we've got this array of 6 holes surrounding the lower hole. So let's jump in and have a look at how we might do that. Begin, as always, by creating a new part, and we're going to save that part straight off the bat, as we always do. It's just always safer than, not saving your part till halfway through, your computer crashes, and then you cry yourself to sleep. So let's go Shift P03. We'll save that as the part name. For description, we come up to File Properties. We say property name, description, and that is side plate. Okay. And I'll just hit save on that. Now I'm going to draw on my right plane. For now, I'm just going to quickly turn something off, and then I'll tell you why I did that a little bit later. So let's draw on our right plane, and I'm going to create a sketch. And I'm going to do something pretty cool which we haven't seen yet using the line tool. So if I select this tool, we can see that I can draw linear lines like so. I can sort of drag it around and it's pretty free flowing. I'm going to drop it somewhere about there. And once I click down, I can then draw another line. I can just keep doing that for as much as I want. A nifty trick, if I bring this line tool and hover back over the last point I drew, my line tool magically turns into a big old curve. So I want to actually use that. I'm going to drop it down there. I'm going to pull another line up out of there. See how it just keeps going? I want to bring that up until it's level with my other line. And then I'm going to come back over so I get another arc. And that's not actually the arc I'm looking for. If I want to try something else, I just hover back over again. Try pulling out in a different direction. And I can drop that down. So here is that first shape I was looking for. Now I've just pressed escape once or twice to get out of that line drawing tool. And I can see this is sort of all a bit underdefined. We've talked about underdefined sketches before. You can tell this is underdefined, one, because it says underdefined down the bottom. That's the dead giveaway. And second, because all my lines are still blue. A blue line is underdefined. And I can see as I drag that what that means. There's quite a lot of geometry moving around there, and you can see that top point is going out of tangency and becoming sharp. So just to start locking this down, I'm going to drag this center point of my bottom arc onto the origin, those red lines, those red arrows, and just drop it down. That means that now the center point of my arc is coincident to that point. It's locked in. And I can't move it. So that's actually fantastic. I don't want that to move too much. The next little bit of information I'm going to put in is I'm going to select, holding control, select that arc and the line that made up that edge that was losing tangency. And I'm going to place a tangent relation on that point. So now I can actually see there was already tangent relations on my other 3 points. It was only that one that was missing. So now if I grab the top, I should be able to click and drag and see what's underdefined. So I can see that, that center of the top arc is actually moving from side to side when it should be nice and vertically in alignment. So what I'm going to do to lock that out is hold control, select the center point of my top arc, select the center point of my bottom arc, which also happens to be the origin now, and use a vertical relation to lock those in line vertically like so. Now if I click and drag, that should only be able to move up and down, and that's a lot more controlled already. So That's about as far as we can get with relations. Now to finish defining it, we're going to need some dimensions. So let's look at what we have. The only thing we get given is that this is 90 millimeters. If this is a side plate, let's assume the largest section is going to be a similar diameter to our pulley wheel, and we'll see if we've been given a dimension for that. I don't see anything actually. So we're just going to have to guess that based on scale. So I'll come to Smart Dimension and I'll put in the only dimension I do know, which will be the dimension between the top and bottom. And that dimension is 90 millimeters. As for the rest of it, it's just going to have to be an estimate. So I'll try move this around until it looks roughly like the sketch. I should be able to click and drag those edges. See, like this, and try manipulate it until I like the shape and think that it looks something like that sketch. That sketch actually, you know, it's really quite slender, maybe something like that. So I'll now drop those dimensions on. Let's have a look. I think that's actually a little smaller in the sketch again, so I might drop that radius down to 20. And for the bottom radius, let's say that it is it's probably pretty close to that. Let's just put in 35 for now. Remember, in SolidWorks, we can come back, we can adjust these dimensions with quite a lot of ease as we start to understand the parts more. All right, now I might put in those holes at the top and bottom. And I'm going to guess they're a 10 mil hole, again, for that 10 mil bolt. So I'll just add those in now by drawing a circle. That is coincident with the centers of those two holes. So there we go, two circles, both coincident with the center of those two holes. And I want to put a 10 mil dimension on those circles. So I can chuck that in like so by using Smart Dimension, clicking on a circle, and typing in the dimension. Now in SolidWorks, we don't want to repeat ourselves too much. It's not good. So I could put a 10 millimeter dimension on this hole as well. And that way I'd have two 10 mil holes, but it's repeating myself and I don't need to do that. The alternative is if I hold Control, I can select my two circles that I want to be the same size. And I can add the equal relation in from the side toolbar there. Just like that. And there I have my egg shape with two holes in it. Now we're missing the holes around the outside, but I want to come back and I want to do those in a separate feature and sketch, just so that I don't over clutter this sketch. I don't put in more information than, you know, needs to be seen at once. So we're going to do something a little bit different. We could use the extrude boss here, but we've actually got a much better feature for working on these flat sheet metal parts. If we right click anywhere in this blank toolbar area, we get our toolbar options and we can see a whole lot of different toolbars we can turn on depending on what we're working with. The toolbar I want to turn on right now is the sheet metal toolbar. So I'm going to just click sheet metal there and we'll see this toolbar appear at the side of the screen. Now, if you can't see it there, just have a look around. Toolbars can kind of open anywhere, depending on if you've opened it before, if someone else has moved it on the computer. So just have a look around the whole of your user interface if you can't spot it at the left-hand side here. You can also drag that around by grabbing it from the dotted section. We can even move it into the top. Famous last words before the whole thing freezes. There it is up there. Or to the side. But I just like it here where it was, so I'll move it back in there. Now the tool I'm going to use is this first one, Base Flange Tab, and that's going to use our sketch to create a flat sheet metal component. Now here we can select all our settings. I'm going to set the thickness for now just to 2 millimeters. The K factor we don't have to worry about at this point, and everything else is all looking pretty happy. So let's just set our thickness to 2 millimeters and hit OK. So that doesn't have any, it's not making any major difference to us right now whether we've done that in sheet metal or as a boss extrude. But later on when we go into a drawing mode and we're trying to make drawings of this, the fact that we've used sheet metal actually gives us a lot of handy information that our drawing can use to just properly define and let a manufacturer know what we're trying to do with our part. So now let's just put a little circle array on the bottom here and we'll be done. So I'm going to right click this flat surface on the front, remembering we can sketch on any flat surface. And I will draw a single hole above my existing hole. I'm going to put a dimension on that, which will be, let's say about 10 mil. Let's just assume all the holes are the same size. That way, if we're making this on a punch or something like that, rather than laser cutting it, we can use a standard sized tool to create all the holes. You know, we don't have to have a tool change on our machine for that. So, now I want to come to this section near linear sketch pattern. And I'm going to choose a circular sketch pattern. Now this will need a center for that pattern. I'm going to select the center of this circle, and it's going to need an entity to pattern, and I'm going to select this circle here. Now I want to change a few settings here. I want to change the number of instances to 6, and all my other settings are fine. It's equally spaced, and it's patterning around a 360-degree circle. So I'll hit tick. And I can see my sketch is actually really very underdefined. So I'm going to click and drag some stuff and just see what moves. I think one of the first things I could do to lock this down is select my top and bottom circle and put a vertical relation between them to help lock that down. The next thing I could do is grab this center point of my pattern, which doesn't seem to be mated down to anything, and just drop it on my origin in the center of that bottom circle. That'll help lock that down. And then finally, I might dimension the distance between the top and bottom holes. And let's call that something like 45. That looks pretty close right now. Now you'll also notice here we can name our sketches. So I might want to call this dimension PCD, meaning pitch circle diameter. You can Google that if you want a bit more information. But it's a standard term for dimensioning, you know, the radius or the diameter on which some mounting holes or any kind of hole really sits. Now there's also another little thing we can do. If I double click on that, we can now see that it's labeled as PCD. But I could also, in my dimension text area at the left hand side here, add PCD. Just type that in, and now I can see it appear on the dimension as well, just so that that's a little more clear in its labeling when someone comes in to edit this sketch. So that's a nice fully defined sketch. Let's jump across to features. Extrude cut, our trusty old friend. And we'll just do a through all cut because these are holes, and hit the tick button. And there we have it, our P03. So I'm going to hit Control S on all of that. You can close your part and you're ready to move on. Very good.